Now we move on to session 12 of our faculty development program. As the world accelerates towards renewable energy, floating solar power is emerging and as a promising frontier. To enlighten us on this, we have with us Dr. Tanay Chattopadhyay, who will deliver the session on topic floating solar power plant, its challenges and opportunities. Dr. Chattopadhyay has worked extensively in solar power projects planning and implementation. His talk will explore the technical, environmental, and economic aspects of floating solar power, along with its immense opportunities. He is working at power plant industry for nearly 24 years in West Bengal Power Development Corporation Limited, Government of West Bengal, enterprise. Presently, he is at the solar division in the company as assistant manager. He is in research work from 2009 in the field of uh, optoelectronics and photonics. He has published nearly 150 papers in international and national journals and symposia proceedings. He is a reviewer of several reputed international journals like Elsevier, IEEE, IOP, Springer, Optical Society of America, etc., and also listed in top 2% scientist list of the world, Stanford University, USA. We are truly privileged to have him with us today, and we eagerly look forward to his lecture on floating solar power plant, its challenges and opportunity. We extend a warm welcome to you, sir, and request you to take us through your expert lecture. Over to you, sir.
Thank you. Thank you. And I am Dr. Tanay Chattopadhyay from West Bengal Power Development Corporation. And first of all, I want to thank to the convener and to give the opportunity to present here about the floating solar power plant. I am here for that talk. Okay, now I want to share my screen. Okay, if it is visible?
No, sir. Now it is visible.
Now it is visible. And the full screen, why it is not appeared in the full screen?
Sir, you press on slideshow, there it will come.
Okay. Okay, I am telling about the floating solar power plant system and its challenges and opportunities. And first of all, I want to tell about my organization. I am from West Bengal Power Development Corporation, which is the electricity-based generation company and supply the state grid of WBSADCL West Bengal. And total installed capacity is now present 4265 megawatt, and which is around 50% of the state installed capacity. And ongoing project is near ongoing project is 660 megawatt supercritical unit, which is first in the West Bengal, and it is at Sagardegi, Murshidabad. Oil synchronization has been done, and it is at the very advanced stage for the synchronization. Secondly, for the green energy section, we also do many green energy projects, that is like rooftop solar, ground mounting, and floating solar project. And we then developed 51.54 megawatt total installed capacity, and ongoing solar project is 31.5 megawatt solar project. And future plan, we have also a future plan to develop 200 megawatt mega floating solar plant with BSS as Bokreshwar Dam, Birbhum, West Bengal. And it is now at the DPR stage, and it will be very near to the tender floating stage. And now, at first, I am telling about the what is the solar resource map. That is global horizontal irradiance. You see that this is the this region of India, that is at Gujarat and Rajasthan, and at the southern region of India, it has a higher global irradiance. And at West Bengal and Bihar, and the north east region, the solar irradiance is very small. So it is obviously that India grows with the solar generation at the western region of that portion, where better irradiance can be found. And actually the solar, every solar panel is acts actually 100 watts per meter square irradiance actually. And it is better good at the Gujarat and Rajasthan. And we are trying also at West Bengal region to develop the solar power plant. And here, for the solar resource plan, we see that this is a solar spectrum where we see the visible range is 380 to 780 nanometer range. This is the visible range, and the solar panel is act in that wavelength region. And infrared is also harmful for the solar region. Infrared is also harmful for the solar panel, and the UV is slightly. So actually the solar generation happens for the visible spectrum region also only. Okay. And now for the what is the problem near this is the main problem for the near generation, that is the water body rise. Actually, the water data sheet shows that the losses we lose, the evaporation loss happens from the various lakes and water bodies of the planet. And actually, a report of the Nature Communication shows that in 1985 to 218, total 1.4 million global lakes are destroyed and evaporation happens. And what is the evaporation rate? Evaporation rate is EV. This is equal to ETO into A into 10 to the power minus 6 kilometer cube per year. This is the unit evaporation rate. And actually, the ETO is the reference evaporation rate. This is depth is millimeter. We consider for India this range is actually 2 to 5 millimeter per day. Actually, the evaporation rate, and this is the main problem. And the what is the excellence of the floating solar project? Actually, floating solar project, we use the water bodies. We do not use any lands. So no requirement of land to install this project. And people get green energy power with lesser price. Annual huge amount of water saved from evaporation. That is, evaporation loss also decrease by using this type of floating solar power plant on the water bodies. And it saves annually 0.92 tons per megawatt hour of carbon dioxide emission, and no cutting of trees required during the project during the project. And it generates also the employees of the local people and enrich the skill of the peoples also and the employees. And is water clarity reducing, which is the biological oxygen demand is also decreased, such that the unwanted algae growth in the water is also decreased. And it is also experimentally proved that the fisheries can be improved with this type of installation program, and more power can be generated by increasing the PV panel, because it is near to the water. So the panels heating up decrease. So the efficiency of the power plant is also increased. And now, what is that? In the case of floating photovoltaic installation capacity, it is a data that is in 2015, total 68 megawatt peak installed. Yes, what is? Okay. Hello. Oh, no. And at 2020, it is increased. That is 500% than the increase than the 2015, and it is increased day by day. And now, the overview is actually the total solar power, that is solar photovoltaic panel, are at the water bodies, and we can also place the inverter and transformer on the water bodies, but also it can be placed on the nearby shore, and from that shore we can make the transmission line. And this the estimation of first of all, we want to tell that this is the estimation of energy generation, and then site selection is important, and design of floating solar plant, and evaluation of the energy generation, then financial outcome and ecological sustainability should be developed, and which is benefit for the agriculture, pisciculture, and tourism, and which is decrease the evaporation losses. And this is the main advantages of the floating solar power plant. And now, this is the other schematic diagram, that is the when we place the inverter and the transformer at the shore area, that is inverter at the shore, and the transformer is there. From the photovoltaic panel, the total 1500 volt DC is come, and it is inverted by the DC to AC by the inverter to 690 volt AC, and then it is step up to the inverter transformer to 33 kV, and which is again it can be transformed to 132 kV step up transformer.
Civil diploma ಅಂತ ಯಾಕೆ ಮಾಡಿದ್ರೆ ಕಂಪ್ಲೀಟ್ ಥರ್ಡ್ ಸೆಮ್ ಅಂತ ಮಾಡಬೇಕಿತ್ತು.
Transmitted by the transmission line. Okay, and this is the control room is there to control and monitoring the total system. And now, this is a picture of floating solar plant of the Kayankulam, Kerala. This is a mega floating solar park. This is called the mega floating solar park, where inverter station and the inverter duty transformer and HT panel all are you are seeing that these all are floating here. And now, what is the execution step of the floating photovoltaic panel? That is, first site assessment is the first one. Then environmental safeguard analysis is important. Then social safeguard analysis is important, and designing and engineering is the important. Then permission and regularity commission should be required. That is what tariff is fixed up for that generation and for the this power purchase agreement. Then after that, the floating platform assembly design and the panel assembly is required, anchoring mooring is required, and then cabling and wiring, and after that, the transmission of the power. This is the total steps are there for the execution of the floating photovoltaic system. And now, first of all, I want to tell about that environmental safeguard assessment system. That is, you can to execute a design of your area, an environmental safeguard assessment should be necessary, because for the actually the solar plant is generated for the next it is installed for the next 25 years, and for during this time any hazard if come, then we have to check that the region is hazard free or not. This is first you have to think. And website is there, that is think hazard website, and if you click to this website, you get this get into this website, and you found this is an India, and here you can give the location. That is, if you enter here the Samastipur, Bihar. What is the spelling? Samastipur, Bihar. You get the total information of the region. If it is the what is the condition of the weather condition, that is in Samastipur, it is shown that river flood is high risk region, water scarcity is high, extreme heat is high, wildfire is high, urban flood medium risk is there, and urban and earthquake is medium, cyclone is low, and landslide is very low, and also the coastal flood, tsunami, volcano, there is no issue at there. So from this region you can get the design, and how you have to design and how you have to consider the project planning and the decision. You can decide from this data. Okay, and the recommendation, and you all that you get, that is what is the recommendation, what is the technical exercise, and you have to get from this website. Okay, and now I am just going to the main theme, that is where it is. Ah. And from this, and then what is the environmental safeguard assessment and social safeguard assessment? Actually, the total safeguard we have to consider, that is environmental assessment, natural habitat, what is the water body near, what are the habitats are there, and the pest management system should be considered. The why if there are any issues are there, you have to, and the mitigation plan, you have to consider the mitigation plan also, which is also included for the DPR section, such that you can get the loan from the World Bank or the number, something like that. And physics and the physical and cultural resources should also be thinking. That is, if there are any monuments are there or historical places there, during execution, if it is destroyed or not, you have to mention all the things. If it is the land is inside the forest, you have to take the permission from the forest department. And also for the dam, if you make the floating solar platform in the dam, then you have to think about the dam safety. Okay, and now what is the social safeguard planning? What is the identification of the project impact area? You have to think that, and then you visit to the villages and talk to them and collect the collective information from the government office also, and also talk with the local peoples. If the project is executed, what will be the benefit of them and what is the problem of them to execute the program and the project at that region, if there are any problem or not, if any we have to consider all the cases actually, and the social economic survey should be done, and proper gender assessment planning should be there, such that you have to make the this is the before execution of the project you have to consider. And now for the where you have to make the project, this is the water bodies, like consider the dam, and you consider you have to take the data actually, what is the lower level at the summer time, what is the normal water level, and if there are any flood history there, and what is the dam opening rate in the year, if it is open for the in which time, then what is the velocity of the water at that region, if there any storm is happen at that region. This is the main data you have to take for the design purpose actually. Okay, so this data is very much important. And now this is the actual detail engineering before the dam. This is the detail engineering for the dam survey, because you have to take the bathymetry study first. That is, what is if there any undulation at the bottom of that dam. So you have to consider it. Then geotechnical survey, water sample collection should be required, and the bed slope should be taken. This survey should be required, and the topography survey should also be required. Okay, and the historical hydrographical survey, if there any flood is there, this should be done, and this is acoustic Doppler Doppler survey should be Doppler current profile actually. This is a sorry, this is a Doppler current profile. You have to think, and this is the different condition, the wave during the storm is happening, then the what is the water current, and geophysical survey you have to study, and the grid what is in the during the power evacuation time, what you have to follow, the route. This route should also be finalized before execution of the project. Okay, and this should be done at the time of DPR, such that it can be easily approved and you can apply for the project. Then the project execution can be done. Okay, and here for the project execution, what is the main thing? This is the main thing, that is the floater. Floater is the main thing of that project. What is this? This is floats on the water bodies, and there are actually 4 type of floats is there: the main float, secondary float, and other is the tools float, which is keeping for the tools for the maintenance. And This type of secondary float is two types, that is small and big walkway. This is the walkway. This walkway is for the reach to the panel and cleaning purpose, maintenance purpose, all are required. And the connectors can be done by the connection pin, that is lock nut can be done here. This is the connecting hole such that the different floaters can be mounted by cascading of different floaters can be done. And total the size of the floaters is there. This is the average weight is 8 kg, and this floats on the waters actually. And this is all are made by the polypropylene and HDP material and UV resistant. UV stabilizer is there, also UV resistant, and it is less corrosive. Huh? And other is equipment floaters, which helps the instrument during maintenance, and also there is a spreader bar. This is the spreader bar. This is required for the this is the aluminum. Actually, this is made of aluminum or the SS rod, and which is the actually required for the mooring purpose. And the mounting structure is on the main float, and such that the PP panel can be mounted on it. This is the fixing system on the mounting platform. And now for the execution, this is the main thing of the floater. This is the HDP UV resistant stability IS 15410 2023, and the floater shall be halogen silicon free. That is, it is also less corrosive material, and this is for the less hazardous material, and it is made of, and it is also resistant of acid, alkali, petrol or mineral oil, and also it is the tested in the laboratory for Central Institute of Plastic and Engineering and Technology. It is also tested, and this certificate should be required before it is applying to the before buying, such that no microplastic can be generated to the waters actually. So this is a high quality plastic body, and after cascading we can make the rolls. Okay, and here the module are placed at angle 5 degree, and you can increase this angle. And the next section I am discussing about this. This is the main installation of floater section. That is, if you have to place first taking the module and put it on the main floater, and this is the step 3, and cascading the two main floaters, also cascading this. You can make an array. Actually, you can make an array, and then it floats to the water. Okay, and this is the preparation of launching pad here, and this is in our power plant. We make this type of launching pad where the floaters and modules assembly is done in this region, and this is friction free pad is matted on that floor, and it is beside the pond area. And this is the module assembly platform, and we make a bench, actually module mounting table, and on the table we take the floaters, and with the screw nut we are jointed the module, and this is another picture, and this is actually the picture of our power plant, Sagodegi floating solar plant of 10 megawatt floating solar plant. And This is the picture. Also, the after the mounting. Sorry, after mounting the floaters on the modules on the floater, what it look like, and making the array. This is the making array, and you then just put it down to the water for the floating. Okay, one by one cascading. Okay, you apply the one by one to the water. And now what is the problem? Sorry. And this is the technology for mooring design. Now for the mooring design, you have to float the floaters on the water. Then you have to mount it such that no disturbance of floaters of no disturbance of wind or during wind load. It is not destroyed. So you have to put a mooring and anchoring system to the mount it actually on the water. That is first for the mounting system. We actually help the CFD modeling with the first making the geometry and meshing the total mounting structure. Then it is we consider the for the constraints here for the CFD modeling, that is ARs surrounded by the panel. We consider the wind load, that is 200 kilometer per hour. If wind happens, then it can be cannot be destroyed. Then we also vary the angle of whole array, that is 0 to 315-degree twist. It can happen for the array, then no problem happens, and we use the K minus E turbulence model of the ANSYS, and the wave height we consider, that is we consider the 2-meter wave height, the variation of wave height 2 meter, and water level variation. We also considered the water level variation. And here after this calculation, we also tested get the viscous drag and the pressure drag we get from this CFD modeling, and it is also tested with the wind tunnel test. Actually, this wind tunnel test we performed in IIT Guwahati. Actually, the wind tunnel test has been done, and after the wind tunnel test, we get the total tension of the system of the total floating array, and then this type of floating system and anchoring system is considered. That is, this is the technique. A simple mathematics is there. That is, if wind is happened here, then total array system is moving towards the right actually. And then what is the tension of the wire? This is the tension of the wire, and this tension actually have the vector component, that is vertical and horizontal, which is vertical component is balanced by the total array system and the wind load. And by considering this, we calculate, and this is the total platform tension we consider for the 5 megawatt floating solar. Actually, the design we make. This is the different anchoring wires are there, and it is placed, and the total tension is distributed among the wires such that the total system can be hold it up on the due to the wind load. And this is the anchoring, and the left hand side you see what is the by animation you see what happens during for the consider the when the water is filled, the movement of the total system is moving from left to right. When low water level, this is the movement area for the floaters, and when the water dries up, it's just landed on the ground. No disturbance happen for the cases actually. And this is what type of mooring system you can use. That is four types of mooring system actually we can use. That is a catenary system and taut mooring, and this is the complaint mooring, and the rigid piles happens and rigid moorings is can be done. And among this, we use the catenary mooring system in our design. Actually, taut mooring system, the thread is the very costly. This mooring technique is very costly technology, and this is various design can be done for the mooring technology, and it depends on the project side also actually. Okay, and here actually in our power plant, how the mooring system is done. Here first by this drilling machine, we make the this is the anchor plate actually. For the there is a rope and anchor plate is there, and first we place the anchor place towards the ground, and after it pulls. That is during pulling, it is just flip, and the total load happens, and during pulling we applied 1000 psi load to the wire, such that during that is the our desired calculation of the tension of everywhere. And after this is the mooring technique actually. And after mooring, the total system is you see that we have actually 5 raw water ponds at Sarodigi, and this raw water pond is used for water for the thermal power plants. There we make the floating solar on that region, and first floating solar was done as 220 at the year of 220. First solar plant was done at now at 225. That is in this year. If all ponds are the floating 5 megawatt floating solar plant is erected, and it is total 25 megawatt floating solar is now installed there. And first execution was done 2nd December 2020. And this is the total capacity was there. This is by MS Well, and otherwise different vendors are there. Amara Raja and UT Universal Transformers and Bikram Solar all make this type of arrangement there for the 25 megawatt floating solar system. And for the checklist, we have to make for the checklist for floating and the mounting structures checklist. We followed this. That is the for the suitability of the project area, size of the objects, suitability, the local site condition with relevant factors, properly surveyed, and the supply tracks record, actually the proper scheme method, and the detailed part replacement procedure, you have to follow it, and the warranty, durability, you have to follow this type of floating and mount structure checklist. And also for the actually mooring system, what is the soil condition? For the soil test is
required, and what is the by the soil testing you get the considered duration, and also for the drag force the proper engineering required before installation of the floating solar, and the suitability for the water depth you have to follow it, and the long-term reliability and durability is also is the main issue, and inspection and maintenance schedule costs and associated costs will be maintained. And also the key components for the section checklist, that is the including PV modules, inverter and transformer, the supplier track records and the experience of the, if it is the suppliers are experienced for the floating solar or not, you have to consider it or think it, and the for the compatibility of the floating structure, weight, dimension, method, an additional test result of certificates is required, then you have to take it from the vendors also, and for enhanced safety condition and the precaution of the environmental requirement, environmental safeguards should be followed such that no environmental or hazardous material can be contaminated the environment to damage the local habitat or also the local people for this project. Okay, and for the general engineering design checklist, you have to follow the proper tilting, orientation, and the interrow spacing in the line of the floating platform. That is, we in our design we make 5-degree tilting actually. For this is this tilting is considered for the calculation by the calculation by the wind load actually. Calculation of wind load. If the wind load, if we increase the tilt angle, then the wind load increases and the mooring cost will be increased and it will be unstable. For the optimum condition, we have to consider for designing the this floating solar power plant, and this is the proper energy, and we have to study the origin and the soil, the part soiling actually it disturb the floating solar surface, and you have to clean it regularly or certain period, and you have to maintain a certain DC to AC ratio. We in our power plant we maintain 20% DC to AC ratio is there, and in some power plants they also use 40%, and it requires it depends on the availability of your area, how you consider the DC AC ratio. Also, you have to think about the inverter capacity such that the DC AC ratio can be overcome and can be maintained by it. And also the design, engineering design, you have to select the inverters and transformers such that the generation can be, the maximum generation can be happened at the peak time, during the peak time. And for the compatible with the environmentals and requirement, which is the system. Moreover, that the system design and the construction of the plant should be compatible with the environmental requirement. And now, for the cost of the floating scenario, we compare. This is a comparison of the floating solar and the ground-mounted solar. That is in the module cost is same. Module cost. Inverter cost is same, but the structural cost is higher than the land cost, because here you have to make a design of the floaters and you have to dry the floaters, and also for the high quality plastic materials such that it can be durable for the 25 years. It cannot be damaged for the 25 years. After 25 years, it should be maintained the quality. So we do not compromise with the quality, and also the plastic quality should be high quality such that no microplastic can be contaminated with that water, and this type of also it is UV protected, and the mooring cost is also increase the cost of the structure, and the high quality mooring structure can be used. Okay, and the balance system which is slightly higher, and the installation and commissioning part, this is more sophisticated installation, should be maintained, so it is less higher than the normal solar system. But the civil and general works, it is lower costing, because if you make it at the ground mounted, then the total proper footing and the ground maintaining a cost, civil cost was there, but here is no civil cost. Actually, the civil cost is distributed to the structural cost. Okay, and for the land and water body cost, we do not require any land actually. Small land is required only for the transmission purpose, and the actually the control room, and all the total panels are on the water. And water body cost, if it is a private water body, then you can easily use the water body. Otherwise, you have to make the water body, use the water body such that the fisherman can get fishing on that water. Or if it is not done by the fishing, then it is okay for the site. And okay, and if it is for the private water body, and like our water bodies, which is only used for the water for the power plants, also power plants water, so we can easily install there. There is no issue for fishing or other purpose, bathing or something. So we can easily use it. And for the transmission cost, which is less, I think it is less. It is nearby. It is installed such that the nearby transmission line is there. Then we can easily put it up to the there. Actually, we hook it up our transmission to that point. And for the this is the actually the main cost is the structural cost here. Actually, the main cost is the structural and the module cost. Module cost is always same for the floating and the ground mounted. Only the structural cost is here, but floaters are the significant cost. Okay, and now for the challenges, there are too many challenges in the floating solar. That is, the investment cost is the main challenges, and then the it is near to the water, so moisture content can affect the module. So module leak proofing is the main thing. So during preparation of the module, you have to make a contact with the module supplier such that this type of arrangement can be done easily. And also the on the system component, also the natural calamities, that is heavy wind load and the storm, cyclone, flood, tsunami, etc. You have to consider during this condition. And the for the this is the generation cost is slightly more than the uh, ground mounted, but as it is if we design our system such that it can also be near to the ground mounted generation cost, and also the it is we get more CUF than the ground mounted, because it is near to the water bodies. So generation is greater than the ground mounted floating solar. So it is very good for that reason. And the evaporation loss is decreased. I also mentioned that so the salinity of the waters is maintained actually. And the water surface should be cleaned. This is the challenges. And biodiversity may be affected. Aquatic biodiversity may be affected. So we have to follow that such that no biodiversity cannot be affected during this execution. So we cannot fill the total water bodies with the panel such that the biological oxygen demand is decreased. So at that region we have to we can fill it up to 30 to 40% of the or sometimes 50% of the water bodies. If this is required for the biological oxygen demand, the testing should be required and proper monitoring should be required, such that the oxygen level of the water is decreased or not after installation of the project. And nearby and the water quality checking should be required, such that any contamination of the plastic in that water is happened or not. This should be maintained regularly if the water is used for the any drinking purpose or something like that. If it is not for the drinking purpose, so you can easily design there. Okay. And nearby grid requirement is also which decrease the generation cost. And now this is the solar glare which is attracts but and oil seepage of the transformer if the transformer is on the platform of the water bodies, then the oil seepage can be done happens. And to decrease the oil seepage, we can use the ester oil, that is the decrease the this type of risks and contamination of the water. And this also is available now, and it is costly, but it should be used for the environmental benefit actually. And also we have to check the maintenance such that any cable is submerged during the evacuation of the water power from the solar system. If it is inside the water, then we have to take the marine cable. Then the cable cost will be increased, and the biofueling is also happened for the water cable, and this also be cleaned up for a certain period. You have to check it up. Okay. And for also the main thing is called the bud drops. Is there pollution can happen. Overeating can be happen. Or by the thermal imaging, you can easily detect it. And by the overeating and the shadow effect, by shadow effect, the overeating is generated. But in the water, if we make the floating solar on the it is all the in the water there is no trees actually at the water, Surrounding it may be trees, but at the middle of the water, no trees. So the shading can be decreased. Okay, see, shading is no shading is there. So overheating chance is reduced, and also unwanted biological growth happens. You have to check biological growth happens. Okay, and this is the environmental stresses that is which has the higher impact. For the moisture, floating solar has the higher impact. So you have to design the module such that no water is engaged to it. And the mechanical stress is also higher impact. And hotspot shading is also not the higher impact, it is moderate. And also the UV, it is also moderate. Okay, and the high temperature because we use the UV protection at the module, at not at the module, at the plastic we use, that is the floater. We use the HDPE material, which is also UV resistant. It is it is tested in the laboratory with the spectroscopy is done for the material to detect it. And high temperature, this is the low impact because it is it is placed near to the water, so temperature of the panel is reduced, and the low temperature effect in our climate scenario in India, very low temperature below 0 degree, there is no happens at that places in West Bengal, Bihar, or Gujarat, or other places. And the temperature cycling, no disruption of the temperature, that is the temperature difference is much not greater, such that the micro cracks can be developed on the solar panel. So these are the challenges. And the big challenges of the you also see at the newspaper, that is Indore Omkareshwar Dam at the initial stage, that is Times of India reported that during cyclone it is some panels and floaters are destroyed, but it is not actual. This is at the floaters which are not properly anchored actually, but that is at the stage when it is built up, at the building stage. At the building stage, you think that no proper anchoring mooring is not done at that time, and cyclone comes. Then what happens? Some of the panels which are not properly anchored is destroyed. Okay, and it is rectified, and it is now placed at that proper place, such that so during the execution you have to think that when the all material comes to the site, and when proper anchoring mooring system you have available, then you have to make this type of arrangement at that time. Okay, and the main problem was the central, that is when the water is ingressed into the panel, then micro cracks are developed, and calcium carbonate and silver carbonate is deposited on there and make it this type of traces, and then this damages, actually the panels are damages. And by the in the floating solar, you have to check maintenance should be done properly, and the cleaning should be required for the module, such that you have to clean a proper, that is cleaning techniques are water free and water based, and a robotic cleaning system can also be done for the sophisticated purpose. And the mode of after all, you have to make the maintenance section, that is preventive maintenance, should be done actually. So this type of maintenance should be required, that is preventive maintenance, corrective maintenance, and predictive maintenance you have to follow. And you have to engage the people checking the module at different places. If there are any cables are loose or that is, you have to tighten it tight the checking the, and if any cable is submerged into the water, then you have to make them in the proper places. This is the preventive maintenance. And if the breakdown is happens, then you have to make the corrective maintenance. Actually, when breakdowns happens, you have to do the corrective maintenance, and such that it can be normalized as soon as possible to generate, such that no hamper of generation can be done. And we can for the solar power plant, it is the maintenance system is easy, because at the after evening you can easily do the maintenance. Actually, that the night time when the solar is not sun is not at the sky, then you can easily make the maintenance and the cleaning of the panels. Okay. And for the predictive maintenance, you can use a real-time data monitoring system. This is AI-based monitoring system. Actually, it will be for the future generation when this type of predictive maintenance can be done. That is, total robotic system can be predict, and by the AI system you can predict when you have to clean the module, when the you have to replace the modules and the floaters and the oil, transformer oil, and the platform. You can easily detect, and before hazard happens, you can easily maintain. More of all, at the conclusion, we can say that the installation procedure is sophisticated than the normal ground mounted solar system, and the climate study should be done properly, such that you can get a prediction, such that you can get a prediction the longevity of the solar system. That is, if you make a solar this type of floating solar platform in a very seismic area, then it may be destroyed, or otherwise you have to make the high quality mooring system or anchoring system, such that it can be then the generation cost will be high. It will also affect at the generation cost, and the power cost is high then. Okay, and you have to think about that. And the anchoring mooring, you do not compromise with that anchoring mooring material quality, because you the thread or the rope you use for the anchor, this should be high quality material, such that no pollution happens or no tear can be happen during storm. Because by anchoring and mooring is the main thing, the total system actually. And the designing of the circuit is very much sophisticated. You'll see that in this presentation. And now I am concluding my section, and this is the total floating solar platform. It is taken by the drone picture. You see that this is a 5 megawatt floating solar of our power plant. It is a drone picture of that. Okay. Now I'm concluding. And for further query, you can mail me on my WhatsApp. Now, thank you. And if any question, you can put. Okay.
చాలా మంది
If there are any query, hello. Hello.
Hello.
Yes.
Yes, sir. We sincerely thanks Dr. Tanay Chattopadhyay for his inspiring and insightful lecture on floating solar power plant, its challenges and opportunity. He has highlighted about floating solar power projects, its advantages, various components associated with it, their functions, how the floating solar power plant works, and the various challenges they faces, and what are the preventive measures for floating solar power plant. I am sure our participants gained new perspective on future energy solution. We are now open the floor for discussion and question answers. I request participants, if they have any questions, they can ask.